Good morning, all. Welcome back to session number 2. So, this is the table of content for session number 2. So, in this session, we are going to discuss about four-stroke diesel engine, PV diagrams, like PV diagram of Otto cycle, PV diagram of diesel cycle, and the comparison and application of two-stroke and four-stroke petrol and diesel engine. So, figure number 2.1 shows the different strokes, four-stroke of diesel engine. So in four-stroke diesel engine, the cycle of operation is completed in four-stroke of piston and two revolution of the crankshaft. And these are the different four-stroke, that is suction stroke, compression stroke, power stroke, and exhaust stroke. So now we'll try to understand each stroke with respect to this schematic. Okay. So first one is suction stroke or intake stroke. Okay. So in this stroke, at the beginning of this stroke, the piston at TDC only. During this process, the piston moves from TDC to BDC. So after moving the piston from TDC to BDC, the section is created in the cylinder so that the fresh air enters into the cylinder through inlet valve. So coming to the inlet valve in this stroke, so inlet valve is open and exhaust valve is closed. And when the piston reaches BDC, then the suction stroke is completed. Okay, this is about suction stroke. Then second stroke is compression stroke. So in compression stroke, at the beginning of this stroke is piston remains as BDC only. During this stroke, piston moves from BDC to TDC. I mean here to BDC to TDC. And regarding valve arrangement here in this stroke, in compression stroke, both valves are closed. I mean inlet valve and exhaust valve, both valves are closed. So piston moves from BDC to TDC. When the piston moves from BDC to TDC, the charges of the air are get compressed into the combustion chamber. And at the end of this stroke, the fuel, the diesel, is sprayed into the cylinder by the fuel injector. As the fuel comes into contact with the compressed hot air, then it's get ignited and it undergoes the combustion process, or it initiated the combustion process. So this is about the compression stroke. And the third stroke is power stroke or expansion stroke. So during this stroke, the piston is at the beginning of this stroke, the piston is at TDC only. During this stroke, the piston moves from TDC to BDC. And regarding valves, both the valves, inlet valve and exhaust valve, both the valves are closed. Okay. When the piston moves from TDC to BDC, right, during expansion process, the huge amount of power is developed, and that power is utilized to do some useful work in the power stroke. So this is regarding the power stroke. And last one, fourth one is exhaust stroke. So at the beginning of this stroke, the piston remains at BDC only, and during this stroke, the piston moves from BDC to TDC. And regarding valves in this stroke, so inlet valve is closed and exhaust valve is open. And when the piston moves from BDC to TDC, the exhaust gas after the combustion is sent to the atmosphere through the exhaust valve. So this is about the exhaust stroke. Then PV diagram. So here we are going to discuss about PV diagram of both the cycle, that is Otto cycle as well as the diesel cycle. So generally PV diagram is used to describe the corresponding changes with respect to pressure and volume in the system. So first we will take Otto cycle. So first we will discuss about the PV diagram of Otto cycle. So Otto cycle is a ideal cycle for SI engine, and it is also called as constant volume cycle. So because the heat addition will takes place in the constant volume process, that's why it's also called as the constant volume cycle. So Otto cycle, Otto cycle is made up of four different process, that is isentropic compression, constant volume heat addition, and third process is isentropic expansion, and fourth one is constant volume heat rejection process. These are the four process which involves in the Otto cycle. So first we'll discuss about isentropic compression process with respect to PV diagram. Okay, so process 1 to 2, I mean here to here, from 1 to 2. In this process involves the motion of piston from TDC to BDC, and air that is sucked into the cylinder undergoes isentropic compression. During isentropic compression, the parameters like pressure and volumes, temperature, entropy, all the parameters are varies. Okay, whereas the temperature and entropy will get that changing trend will get in TS diagram, but here we are going to discuss only the PV diagram, the variation of pressure and volume. So in the isentropic compression, so after the compression, the pressure increases from P1 to P2, P1 to P2, and the volume reduces from V1 to V2. Here, this is V1 and this is V2, V1 to V2. And along with that, the temperature also increases in the isentropic compression process. So this is about isentropic compression process. Then second process, that is from 2 to 3, from here to here, that process 2 to 3, that is constant volume heat addition process. Okay, so in this process, the piston is rest for some time at TDC. During that duration, the heat will be added. The heat will be added to the working fluid or the air through the external sources. At that time, volume remains constant. That means here V2 equals to V3. Volumes remains constant. So after adding the heat, the pressure increases from P2 to P3, as well as the temperature also increases from T2 to T3, but the volume remains constant in this process, that is V2 equals to V3. So this is about constant volume heat addition process. Then third process, that is from 3 to 4, from state point 3 to 4, that is isentropic expansion. So in this process, the working fluid or the air expands isentropically. In this process, the parameter pressure decreases from P3 to P4. I mean here to, this is P3 and this is P4. It will reduce from P3 to P4, and volume increases from V3 from V3 to V4. The volume will be increases from V3 to V4. So this is about isentropic expansion process. Then last process, that is from 4 to 1. 4 to 1 process, 4 to 1 constant volume heat rejection process. So in this process, the piston will stay at BDC for a particular time period. It will stay at BDC. During that time, during that duration, the heat will be rejected from the working fluid, and the parameters like the pressure and volume also varies. Okay, here from in process 4 to 1, the pressure decreases from P4 to P1, and whereas the volume remains constant in this process. Okay, this is about, yeah, this is about constant volume heat rejection process, that is state point from P4 to P1. So coming to diesel cycle, this schematic, that this PV diagram shows the 4 different processes as we discussed in Otto cycle also. So here also the diesel cycle is made up of 4 different processes, that is isentropic compression. The only difference is in Otto cycle, heat addition will takes place at constant volume, but here in diesel cycle, the heat addition process will be takes place at constant pressure process, whereas the heat rejection remains same, that is constant volume process. So this is the main difference between diesel cycle and Otto cycle. Okay, diesel cycle is also called as constant pressure cycle because the pressure heat addition takes place in the constant pressure process. So now we'll try to understand each process with respect to PV diagram. So first process, that is from 1 to 2, state point, this is 1 and 2. This is isentropic compression. In this process, the working fluid get compressed. So the parameters like pressure and volumes varies. So here the pressure in this process, the pressure varies, pressure varies, increases from P1 to P2 and the volume decreases from V1 to V2. So this is V1 and this is V2. This is isentropic compression process. So second process is constant pressure heat addition process. So in this process, the pressure remains constant, that is P2 equals to P3. Okay, but whereas after adding heat from external source to the working fluid or air, the volume increases from V2 to V3. So this is V2 and this is V3. The volume increases from V2 to V3, whereas the pressure remains constant, that is P2 equals to P3. This is about constant pressure heat addition process. Then third process, that is isentropic expansion process. So isentropic expansion process starts from this point, state point 3 to 4. So here the working fluid or the air get expanded, isentropically get expanded, and the parameters like pressure and volumes varies here, and the pressure decreases from P3 to, so this is P3 and this is P4. The pressure decreases from P3 to P4, whereas the volume increases from V3 to V4 in isentropic expansion process. So last process is 4 to 1, that is constant volume heat rejection process. So here the heat rejection process takes place from 4 to 1 and the parameters like pressure and volumes are varies here. So pressure decreases from P4 to P1. Here the pressure decreases from P4 to P1 in constant volume heat rejection process, whereas the volume remains constant, that is V4 equals to V1, and temperature also decreases from T4 to T1. So this is about the diesel cycle, which includes all 4 processes. So now we'll compare 2-stroke and 4-stroke engines with respect to different parameters. So 2-stroke engines and 4-stroke engines already we discussed in the previous session. So based on that, I have listed some differences between the 2-stroke and 4-stroke engines. Okay, first difference is the cycle is completed in 2 strokes. That is nothing but the cycle of operation of 2-stroke and cycle of operation of 4-stroke engine. So we already discussed that in 2-stroke engine, the cycle of operation completed in 2-stroke of piston and 1 revolution of crankshaft. So whereas in 4-stroke engine, the cycle of operation is completed in 4-stroke of the piston and 2 revolution of the crankshaft. This is the major difference between 4-stroke and 2-stroke engines. And second difference is 2-stroke engines have lighter flywheel, and whereas the 4-stroke engines have heavier flywheels. Okay. And third difference is, so 2-stroke engine normally have 1 power stroke for 1 revolution. So the power generation or the power production is more with compared to the 4-stroke engine. But whereas in 4-stroke engine, 1 power stroke of 2 revolution. So the power production or power produced is small compared to the 2-stroke engine. And the next difference is the 2-stroke engines are light and compact compared to the 4-stroke engine. The 4-stroke engines are little heavier and also bulky compared to 2-stroke petrol engines. Okay, and the next difference is 2-stroke engines require greater cooling and lubrication system, whereas the 4-stroke engine required lesser cooling and lubrication compared to the 2-stroke engines. Okay, so in 2-stroke engines, wear and tear are high compared to the 4-stroke engines. Okay, and next difference is 2-stroke engines contains ports, whereas 4-stroke engine contain valves. So in two-stroke engines, we have three different ports, that is inlet port, transfer port, and exhaust port. Whereas in four-stroke engines, we have valve, that is inlet valve and exhaust valve. And the difference between ports and valves are, ports are just, it's opening or close, it's uh, opening or closing by the piston, but whereas the valves are mechanically operated. Okay, and initial cost for the two-stroke engine is low, whereas the initial cost for the four-stroke engine is high, and the volumetric efficiency is low compared to the four-stroke engine. And finally, last difference is thermal efficiency. Two-stroke engines have lesser or lower thermal efficiency compared to the four-stroke engine. The thermal efficiency basically depends on the losses. So that's why the two-stroke engines having lesser thermal efficiency compared to the four-stroke engines. So this is about the difference or comparison between two-stroke and four-stroke engines. So in this slide, we are going to compare with petrol engine with the diesel engine. Okay, so the difference between petrol and diesel engine. So first difference is, as the working fluid in petrol engine is, working medium is petrol, and in diesel engine the working fluid or the fuel used is diesel. Okay, that is the common difference between petrol and diesel engine. And the second difference is, spark plug is used in the petrol engine. So in diesel engine, spark plug is not used because it's a SI engine. So spark plug is required to initiate the combustion process in the petrol engine. So whereas in diesel engine, the spark plug is not required to initiate the combustion process. So third difference is, carburetor is needed in the petrol engine. So whereas in carburetor is not required in the diesel engine. To maintain the proper air fuel mixture, the carburetor is required in petrol engine, whereas in diesel engine carburetor is not required. And petrol engine emits less smoke. So diesel engine emits more smoke. That emission of smoke, it's basically depends on the combustion process, or we can say it's a complete combustion or incomplete combustion. Based on that, we are getting high smoke or less smoke. And regarding efficiencies, so petrol engine is having lesser efficiency compared to diesel engine. And the last difference is intake stroke. Intake stroke in the petrol engine or in SI engine. Okay, the fuel air mixture enters the cylinder. So in petrol engine, both the fuel and air mixture enters into the cylinder in the suction stroke or intake stroke. But whereas in the diesel engine, the only air enters into the cylinder during the intake or suction stroke. So these are the basic difference between the petrol engine and diesel engine. Next, coming to the application of two-stroke engine. Okay, in olden days, the two-stroke engines are very much familiar or popular in especially bikes and racing cars. But nowadays, almost many countries have banned two-stroke engines due to many drawbacks. Okay, and nowadays the two-stroke engines are used in boats as well as some gardening equipments. Okay, so these are the two important applications of the two-stroke engine. Coming to application of four-stroke engines. So four-stroke engine normally have huge applications compared to two-stroke engines because of its advantages. So first application, four-stroke engines are widely used in the passenger cars and the buses. So this is related to transportation. Okay. So other transport uses means other than cars and bus, the four-stroke engines are used in the heavy trucks. Okay, so other than transportation, I mean non-transportation users, the applications like diesel engines are used in the generators. So these are the few important applications of four-stroke engine. So now we'll discuss about multiple choice questions based on the session number 2. So first question is the thermodynamic cycle on which the petrol engine work is. So here we have 4 options, that is Otto cycle, Joule cycle, Rankine cycle and diesel cycle. So here is talking about thermodynamic cycle on which the petrol engine. Petrol engine means it's a Otto cycle, nothing but constant volume cycle. So the right answer is A. Then coming to question number 2, in a 4-stroke diesel engine, during suction stroke, the options are only air is sucked in, and second option is only fuel is sucked in, and third option both air and fuel sucked in, and last option is none of the above. So in this question is talking about 4-stroke diesel engine. So 4-stroke diesel engine means in 4-stroke diesel engine in intake or suction stroke, the only air enters into the cylinder. So right answer is A. So third question, carburetor. Carburetor is used in options are SI engine, CI engine, gas engine, and aircraft engine. So right answer is SI engine. So carburetor is used in the SI engines. Okay, carburetor is a device which is used in IC engine to prepare correct amount of air and fuel, okay, in proper ratio. To maintain the proper ratio of air and fuel, the carburetor is used in the SI engine. So question number 4, the combustion in CI engine is, options are homogeneous, heterogeneous, then third option is both A and B, and last option is none of the above. So the right answer is combustion process, it's a heterogeneous. Okay, in CI engine the combustion will be heterogeneous, whereas in SI engines it's a homogeneous. Last question. So if petrol is used in the diesel engine, then dash, the options are low power will be produced, efficiency will be low, then third option is higher knocking will occur, and last option is black smoke will be produced. Okay, and the right answer is C, because if petrol is used in the diesel engine, the higher knock will occur in the engine. Okay, so in this slide you can see the frequently asked question. The first question is related to PV diagram of 4-stroke diesel engine, and second question is related to difference between 2-stroke as well as 4-stroke engine, and the third question is comparison between petrol and diesel engine. So these are the frequently asked question, I mean in recent exams. So this is the outcome. So at the end of this session, the student should be able to understand the working of 4-stroke diesel engine and is able to draw or plot PV and PV diagram, only not TS, only PV diagram with respect to Otto and diesel cycle, and to understand the difference between 4-stroke and 2-stroke engine, and understand the application of 2-stroke and 4-stroke engine. So these are the references for session number 2. So with this, I will end up the session number 2. Next, we will meet in session number 3. Thank you.